together a jump state, which I did not rename. Jump state, there we go, for a player, and a landing state so that he can land. So what are we going to do this time? Well, we're going to add in some ducking states, and might as well get started with our slashing states, which are the most interesting states to worry about. So let's get cracking on that. To get us started off, we need to add in some more user events for various different states. Let's see, we need 2, 3, 4, 5, and 6. And last but not least, 8. We're going to need all those in our link side-scrolling state here. And also, come back here to our create event. So if you were paying attention in the last video, you saw that for a single frame, our player sprite was still the sprite link find treasure. So I'm just going to see why that happened real quick here. We know that we have all of our sprites set up, and player's state should be player state.move. So theoretically, when we come to the step event, we should, so if current XP is equal to 0, it should be, so should be set sprite index to sprite link idle. So then we come back over here, and we do have the main sprite change set, so, oh yes, that would be why, because facing direction. So was our facing direction set to no one? No, we set it to left. Left is sprite link walk. And I don't know exactly why I did that then. So we got our current X speed is equal to 0. So when link is created, he should, well, maybe it just doesn't execute during the first loop when he's created. So just to ensure that he does go to the right sprite, we're just going to add in a little thing here and say sprite underscore index equal to sprite underscore link underscore walk. That's simple. That should fix that little flash where he wasn't looking to his, he wasn't in the walking state there. So let's come over here and not delete that. I want to change that to duck state. And like previously, we're just going to come back here. And we're basically going to copy one of our other previous states and use that as a template for this setup here. First thing we need to do is determine what states can we enter into from the ducking state. And our states that we can do are the move, jump, and ducking slash states. So we're going to change you to move and you to jump and you to ducking slash. And in all these cases, we're going to change our code a little bit. So our move state is going to be very simple. If the player presses, if the player isn't pressing down anymore, then if our frames are greater than 0, so if we've been in the state for longer than 1 frame, Otherwise, if you press down and release, well, I guess you wouldn't. This wouldn't be able to actually happen. But so because if it registers a press down, it's not going to change from a press down until the next frame when it would change to the when it would detect it. So that's kind of redundant, that code at that point. But you could basically use this to kind of say, okay, well, I want him to be in the ducking state at least X amount of frames. So, that's something that you could keep that in there for if you felt like it. But apparently it's just excess code that I left in there on accident. So just change back to our move state whenever we aren't pressing down. That's all you need to do. Very easy. As far as acceleration goes, we are going to decelerate. Well, actually, let's go into the jump state real quick here. It's, again, basically exactly the same as for in the move state. If we press the jump button, then put us into the jump state. And basically, the jump code is the same, and though we won't actually be moving at full speed when we're in the duck state because you can't accelerate when you're in the duck state. You can only decelerate. So if I'm on ground is equal to false, set that to false. And if when we're in the duck state we fall off a ledge, again, go into the jump state. All right, so acceleration is going to be zoomed in a little bit so you can see better. Current x speed is equal to approach our current x speed towards 0 by ground friction. All right, so applied x speed is equal to current x speed, and if you touch a wall, stop. And speed fractions should be the same. Yep, they're the same. Just ignore anything else to do with them. And collision movement the same again. And our animation is no animations. We're just counting the frames in the state. So as you can see, once again, our templates pay off. We can very easily move between different states while in various states using it. Let's come back to you. I haven't put in how to get into the duck state yet. And that's very simple as well. Just if input held, 0, input action dot down, change state to duck. So that's all. If you're holding that down button, go into the duck state. But only when you're moving. I can't remember. Can you go into the duck state when you're jumping? No, you can't. So you can't be ducked down while you're jumping, except for the first frames when you're jumping up where you automatically are ducking, because that's the way it just looks. All right, so now, well, I was thinking ducking slash state. Well, let's skip over ducking slash state and let's just go straight to the normal the standing slash state to start with, because well, that'd be most useful. So let's see our standing slash state. Once again, we're going to Control M to close all that stuff. So this is event 4, I believe. Yeah. Bring it all in, hit Control M. What did I do? Oh, there's a script in there I haven't actually created yet. We'll come back to it in a little bit. So in our standing slash state, so we want to be able to attack things. So we hit the, so when we're in the move state, and if we hit some buttons, pull over some code here. So if we hit the negative input, so B button, then we read the input buffer, or reset the input buffer, I should say, our negative, and then we go into the standing slash state. And that will cause us to perform an attack. If we come back over here to our standing slash state, we can go into the jump state from the standing slash state. Apparently, you can jumping can override slashing, and you can slash while jumping as well. But if you're trying to do a slash attack and then you hit the jump button, you can start jumping regardless of where you are inside of the action state. So I wasn't doing any ledge checking because while you're in the standing slash state, you lose all X momentum. You probably should. Yeah, probably should, but I didn't for my reason right there, which is probably a fallacious opinion, a fallacious reason. So, anyways, just go into your front. You reset the input buffer, change your state, go into the jump, and so on and so forth, just like in your movement state. Going into the movement state, if we are tempted to move, immediately fall into the move state. Otherwise, show the follow through image for a few frames. So if we come over here to our sprite, link, sprite link duck, sprite link, standing slash. Link has this one frame follow through, or I should say, it's supposed to be him leaning backwards to get ready to slash forward. It makes more sense if you can see me right now. I'm just sort of in the same position that he is. But then at the end of his slashing animation, so after this, he goes back into this state as a sort of follow through sort of look. So what we want to do here is set it up so that when Link is at the end of his animation, then start showing the follow through. Otherwise, if we are tempted to move, just immediately start moving. Otherwise, you go and do the follow through, and then you fall back into the move state eventually. So if X input is equal to 0, so if we haven't put in any X input, then the frames of state are greater than 60, then we return into the move state, because over down here in our animation setup, we are going to put in the follow through. And if our X underscore input does not equal 0, so if we're pressing left or right and the frames of state are greater than 13, so you're stuck in the if you're trying to go into the walk state, you're stuck in the slash animation for at least 13 frames. Then go back into the walk state at that point. And duck state, basically exactly the same as the move state here. Change state to the duck, and if you are holding down. Then we have the standing slash state, because you can go into the standing slash state again from the standing slash state, so you can just attack over and over and over again, right? So if input underscore pressed is 0 and our player input ID, well, in the future I'll change that to just player ID. At input action dot negative, frames in state greater than 20. So if we've been in the state for greater than 20 frames, we can then go and attack again, because if you're trying to go and attack again, you have to show at least a little bit of the follow through before you can do another attack again. So, etc. As far as accelerations go, the standing slash state cancels all X momentum, so you shouldn't be able to reach a state while in the air, so Y isn't accounted for. Yeah, so because if you're in the air, you'll go into the jumping slash state rather than in the standing slash state. So X fractions are equal to 0, current X speed is equal to 0, applied X speed is equal to 0. You just stand still when you're attacking. Speed fractions, since you're not moving, we don't bother with it. Collisions movement, since you're not moving, we don't bother with it. And everything else is part of the animation at this point. So we are going to go over this here after expanding a little bit to make it easier to see. All right, so this is basically a sequence, and I would make it a sequence, except as it turns out, you can't sort of have an object have a sequence and still be its own object. And it's just really you can't set a sequence as the sprite. That's what it basically is. So if you could set your sequence as a sprite, I would do it that way. But since you can't set your sequence as a sprite, I have to do it this way. So we're going to be kind of going in reverse order here. So if the frames of state are greater than 20, then image index is equal to 0. So if we've been in the state for at least 20 frames, go back into the follow through at that point. Else if frames of state is greater that so by the way, this greater than 20 combines with the going back in the move state. So once your frames of state are over 60, you go back to the move state. So that's 40 frames of showing the follow through animation. Else if the frames in state are greater than 13, then the manual sprite change is equal to true and show the sprite link idle. So between frame 13 and frame 20, you just show the link idle sprite, which is not that one. If frames in state are greater than 7, then we are going to create something that we throw. We're going to create a throwing animation. We're going to create, so Link, when he does his attack, if he has full health, he creates a laser beam from his sword. But also, just at 7 seconds, we are going to create a hitbox for the sword. So that'll be when we actually, so between frames 7 and 13, there will be a hitbox that's alive in the world, that if an enemy touches that hitbox, will count as a hit on that enemy. That's what I should say there. So during this frame period, the image index is equal to 1. So that would be there. But before we go on to there real quick here, I'm just going to mention that during all this time, we haven't set the image speed to anything other than the 0, which it's set to when you change your state because of the frames in state, etc. Sprite. Oh, yeah, there it is. Image speed. So when you change when you change state, the image speed is set to 0. So that's why we are manually changing the image index to whatever we wanted according to each frame. So at this point, if audio is not playing, SFX // yeah, that one. So this lasts for 1 minute and 13 seconds, which is long enough that it's much longer than these 5 frames, or these, what would it be, 8, 9, 10, 11, 12, 13, so 6 frames. So that would give us the sound will last through this period. That's what we're saying here. And it will keep playing. So, I mean, if you were to have your game be exceptionally laggy, so it was unable to complete in 60 frames per second, it's like doing 1 frame per second, this would end up playing over and over again during that time period. But as it currently is set up, it more than easily gates the sound, so it only plays it once while you're slashing. So let's see here. Our time goes. We're at 20 minutes, so that means I have around 8 minutes more to talk about this. So generate a hitbox. Each frame the sword is thrust out. So what we're going to do is we're going to make a DS list here. Call it instances. We're going to make a direction, and we're going to base the direction on which direction the player is currently facing. And we're going to use 1 or -1. And the reason why we have it this way is that so that if for whatever reason your sprites are flipped the other direction or something, it doesn't matter if the image X scale. We're not going to use the image X scale for this because I mean you could, but we're not. Again, image X scale could also be like 0.5 or something like that. So that's the reason why we're not going to do that. So based on what direction you're currently facing, 1 or -1, and we'll use that for calculating the position that you spawn the hitboxes in. So var underscore color. So this is for the draw event, or I guess I should say this isn't color. This is collision. So what we're going to do is we're going to make a collision rectangle list. And this will get a list of every single instance that is touching that rectangular area at that point. So we had to have instances, and we store them in this list instances. So based on this, if the facing direction is equal to right, then we create a hit on our right. Otherwise, we create it on our left. So there's a certain amount of accuracy that has to happen. So if you are, so the collision rectangle, if you are facing to your right, is 1 pixel. So if you're trying to draw it on your left, it'll be 1 pixel shorter than if you try to draw it on your right, due to the way the collision rectangle function is set up. So the way you draw rectangles. So you have to make your rectangle 1 pixel larger on your left versus on your right in order to have it be the same size. So it's really kind of annoying. Otherwise, I could just have it multiplied by this direction variable here directly, and I wouldn't have to worry about that at all. So anyways, we have our X position plus dir times 10. So let's see, that'd be dir 1 if we're facing right times 10. So that gives us, so it'll be our X. So let's say this is our X. So plus 10 over to here. And then X plus dir times 18. So then we go to 18 right here. So now we'll just do that. So from here to here, it's drawing over that. I fear this is probably a terrible way to explain this. So yeah, we're drawing a rectangle. So we need the X and the Y. We need 2 X points and 2 Y points to draw a rectangle, right? So our X position when we are facing to our right should be at 10 pixels and 18 pixels. So that gives us 8 pixels of space between them. And then when we're facing left, our X position should be at the 19 and at 11. So this our X1 and our X2. So our X1 here is 19 pixels away because remember on our left, the left side of the rectangle is always our X1, right? So the X1 needs to be further away from us when we're facing left versus when we're facing right where the X1 is closer to us because it is on our right side at that point, and the left side is where the X1 is. So that's why they're different sizes and going forward and backwards here. It'll be easier to see if we go over draw event, and oops. Just throw in all this debug code, and it'll basically draw the rectangle for you so you can see where they're at. I'll show you in a bit. Not step event, we want the standing slash state. Anyway, so our idea is that we're going to hit parent enemy, so we should need to create that. Over in our parents, create an object, parent underscore enemy, except name it right. There we go. So this collision rectangle list creates a rectangle. Parent enemy is our target, and precise is false. Not me is false. Inst is this list we created right here, and that's where it's going to store all the instances it hits. And ordered is also false because we don't care about order. Then you have this colon here, and then we have the second half of the ternary statement right here. For var I equals 0, while I is less than collision, I plus plus. So what we're going to do here is loop through every single enemy in the instance list. Attempt to damage all enemies in the list by triggering their damage state. And we'll actually just cancel this for the time being. And we'll come back to this when we actually create damage states. And we go over here to destroy our list that we created so we don't end up with a memory leak. All right. Otherwise, image index is equal to 0. So during the first 6 or 7 frames of the state, we're actually just in the pullback image index. All right, so we also have this generate a sword beam when we're at full health, but we don't really have time for that right now, so we're going to skip that for this time being. Image X scale is equal to facing direction again, and frames of state plus plus, because you can flip your image direction while you're in the slashing state, as opposed to some other states where you can't do that, like the duck state. Maybe you can do it in the duck state. I can't remember if I had tested it. Oh, well, whatever. So anyways, so that's how you set up a slashing state. Let's take a look at it. So hopefully you'll be able to see the you'll want to see the slashing, the hitboxes. So you can see right there on the left and right we have the hitboxes being generated. That's where our sword will be. So there we go. You can see he does his little what is it called, the follow through after you do the sword slash. And you can see he stops moving when he's in the slashing state. And again, you can see that Link has a little acceleration setup going where he has to slide to a stop before he starts going in the other direction. So anyways, I'd show you in the ducking state, but we don't have a ducking slash state yet. Yeah, these are just the upper portion. And you can fiddle around with those boxes and stuff if you want. Alright, so I think at this time we are done. So let past me take it away with Patreon sponsors. And thank you for listening. I'd like to thank my legacy Patreon sponsors: James Burton, JD Lowe, Suli, and Vezia. I'd also like to thank my current Patreon sponsors: Kenneth Klein, Vladimir, and Jamal. Thanks to your support, the NESGameMaker is much cooler, and I'd like to wish you all good luck with your programming.